Next step, subtraction of integers. Subtract one integer from another. We take the additive inverse of the integer to be subtracted and it is added to the other integer. Thus, if x and y are the two integers, then x minus y is equal to x plus minus y. So, subtract the following integers. Let's give an example like 9 from 4. Here, when the from comes, you should take the number which comes after from, like from 4. So 4 minus 9. Here, as I said before, 4 minus 9 is equal to 4 plus additive inverse of 9, which is equal to 4 plus minus 5. So the answer is going to be minus 5. Addition or subtraction, the rule is same, that you should give the answer the sign of the greater number in the equation. Multiplication of integers. Multiplication of two integers with like signs. If two positive or negative integers ought to be multiplied, put a plus sign to the product regardless of their sign. That is, if plus into plus is equal to plus, plus into minus is equal to minus, minus into plus is equal to minus, and minus into minus is equal to plus. When there is like signs, the sign is going to be plus, and when there is negative signs, which is unlike signs, we will have a negative sign. So the multiplication of two integers with unlike signs. If two integers to be multiplied or of opposite signs, that is positive and negative, we find the product of their value regardless of their signs and give a minus sign to the product. So if minus 41 into minus 113, the answer is going to be 463. Here, which sign we should put? That you should multiply the signs also. So minus into minus is equal to plus. So the answer is going to contain as plus. Division of integers. Division is the inverse process of multiplication. Dividing an integer a by another integer b is to find the number c, such as that a is equal to b into c. The division of two integers with like signs. Dividing one integer by another integer with like sign is to divide their values regardless of their signs and give it a plus sign into the quotient. That is plus by plus is equal to plus, minus by minus is equal to minus, that plus. So here also the same, that like signs should have positive, unlike signs has to be a negative. So dividing one integer by another integer with unlike signs is to divide their values regardless of their sign and give a minus sign to the quotient. Let's have an example. 168 by 4. Here the answer is going to be 42, and here positive by positive is equal to positive sign. So the answer is going to be positive 42. And let us have another example, like minus 144 by 4. Here the answer is going to be 36 regardless of the sign. And if we divide the signs, minus by plus is going to be minus. Need for the rational number. We observe that the system of numbers called integers does not have an answer for all the questions, like 2 by 3, 7 by 8, 9 minus 9 by 7. These are different. That is, that doesn't have a minus sign. That is not a negative natural number or positive natural number. They are fractions. So to extend to bigger numbers called rational numbers, it is denoted by q. Rational numbers include fractions as well as their negative numbers, like 1 by 3, 1 by 2, minus 1 by 3, 4 by 3, or minus 4 by 3. So we can define the rational numbers as follows, as the numbers that can be written in the form of a by b, where a and b both are integers. That is, b is not equal to 0. We cannot put it as a, or maybe like 3 by 0. There is no system like that. There is a law that the division cannot have 0 as a denominator, or called the these are called the natural numbers. The numbers such as 3 by 7, 5 by 19, and 3 minus 3 by 11 are rational numbers. So here, a division cannot have, a fraction cannot have 0 as the denominator. That is a law. So b is not equal to 0. Representation of rational numbers on the number line. Like natural numbers, whole numbers, and integers, rational numbers can also be represented on the number line. And let us represent the rational numbers such as 3 by 8, 5 by 8, minus 7 by 8, and 15 by 8 on the number line. Draw a straight line with arrows at the end. That denotes that the line goes on infinite in the both sides. Write a 0 in the middle of a line and mark 1, 2, 3, and so on in which numbers you want. And to the right of O, 0, and minus 1, minus 2, minus 3 as we write in a normal integer number line. And the left of 0 with values spacing between them. Leave some spaces between them, okay? Divide the space between two numbers into equal parts based on the denominator of the given rational number. Here it is 8, like 3 by 8, 5 by 8. That is, the 8 parts of something, it is a part of 3. That if I have 8 pieces of pizzas and there is 3 pieces, I can say that 3 by 8 is a part of mine, so don't take it like that. So here I want to divide it into 8 pieces. Here, and then the step number 5 is going to be like mark the required divisions on the scale to the numerator. Represent 3 by 4 and minus 3 by 4 on the same number line. Draw a line and mark O on it. Mark the A quotation at the left side of the O and point A on the right side of O, such as OA is equal to OA quotation is equal to 4 units. As shown, divide the OA and OA quotation into 4 parts. Mark the point B quotation and B numbers on the line as shown. And B quotation and the B represent minus 3 by 4 and 3 by 4 respectively. Represent the following rational number on the number line. Follow the steps. Draw a line and mark a point O in it. Take a point A on the right of it such that OA is equal to 1 unit. Take another point B to the right of A such that OA is equal to AB. Divide OA and AB in 4 equal parts, each 1 by 4. This steps is for the first sum, for example. For the 5th step, mark the point that is equal to the numerator. Okay, first sum, 5 by 4. The answer is given. Second, 3 by 7. Third, minus 7 by 3. And the fourth, minus 6 by 5. In the next video, we are going to see about the properties of rational numbers. The set of rational numbers is closed under the addition, subtraction, multiplication, and division. The properties of addition of rational numbers, properties of subtraction of rational numbers, the properties of multiplication of rational numbers, and the properties of division of rational numbers. They all have common 5 properties. There are closure property, commutative property, associative property, extensions of additive identity or property of 0, and extents of additive inverse or negative of a rational number. And also we are going to see some examples based on these properties.